Three girls, Reshma, Salma and Mandeep, are playing a game by standing on a circle of radius 5 meters drawn in a circle. So Reshma throws a ball to Salma and Salma to Mandeep, Mandeep to Reshma. If the distance between Reshma and Salma and between Salma and Mandeep is 6 meters each, what is the distance between Reshma and Mandeep? So I would like you guys to draw the diagram, right? Mark the things, what is given and everything. Write given and what is that we need to find. So there are three girls who are standing on a circle with say center O. So one person say it's standing, he or she is, no sorry, she is standing over here, second person over here and third person over here, right? Because they're at the same distance, these two people, I'm able to draw this. So say this is the first person, I think that is Reshma and then Salma and Mandeep. So at last Mandeep throws the ball to Reshma. Okay, we have to find RM basically. So this is 6 and this is 6 and we know the radius of the circle, right? And they turn out to be 5. So we have to find RM. How will we do this? So this has to go with, we can use a technique wherein we find the area of, let me do this entire quadrilateral and use it to find the length of RM. Why and how? See, the thing is ORSM is a kite and kite has a particular property, and that property is that the area of the kite is product of the diagonals. Okay, so using this property we'll be able to find the area of or length of RM. So let me start by finding the area of the rhombus. So given a circle with center O and radius of 5 meters, and we have RS which is equal to SM which is equal to 6 meters. And now we are to figure out RM, and let's begin the working. So first part is, let's figure out the area of ORSM by finding the area of ORS. So let me do that. So let's consider the triangle ORS. So we have ORS. This is 6, sorry, this is 5, this is 5, and this is 6. This is a perpendicular line. That's your height basically. See, this is an isosceles triangle, is it not? So consider triangle ORS. So we are looking at an isosceles triangle as OR is equal to OS. Triangle ORS is an isosceles triangle. So O, say M, right? The height of triangle ORS bisects RS. Okay, so the height of a what is that? Height of a isosceles triangle will bisect the base as OM is drawn from a vertex containing equal sides. Okay, so we are drawing from this vertex, so this acts like a bisector. It's a property regarding isosceles triangle. You guys have to be very clear with all these properties. So therefore, height square is equal to phi square minus rs by 2 the whole square. Or let me write it properly. OS square minus rs by 2 the whole square with the help of Pythagorean theorem. Now let's substitute and see how much is your height. So this is 5 square and this is 6 by 2, that is 3 square. So this will be basically, you calculate this, you'll get 4 meters. Okay. So this is 25 minus 9, 16, square root of 16 is 4. So that is 4 meters. So now we know the height, we can find the area of, therefore area of triangle ORS is equal to half into base RS into height OM. So this is nothing but half into 6 into 4. So this is 12 meters. I think I'm right with that. Meter square, sorry. Okay, I didn't miss anything, right? Or this is that 4, yes. 18, sorry, 6, 3, 12. Now, area of ORSM is equal to 2 times the area of triangle ORS. Okay, so reason triangle ORS is congruent to triangle OSM. Right, those two triangles are congruent by SSS congruency. So reason I'll explain it off. OS is common. Then we have OM, which is equal to OR. Right. So these are radius. And we have RS, which is equal to SM, which is given. And so this area will be equal to area of ORSM is equal to 24 meters square. Okay. I think I didn't miss anything. I feel like I'm doing something. I'm missing something. Now, at last, area of ORSM, or consider ORSM. Okay. So we'll write that it's a kite because OR is equal to OM and we have one more pair. RS is equal to SM. Is it not? So OR is equal to OM and RS is equal to SM. Right? So we have a kite. This implies ORSM is a kite. Reason, two pairs of adjacent sides are equal. Now we have a area of ORSM formula which is equal to half into d1 into d2, the product of diagonals. So one of the diagonal is OS, which is 5, and the other diagonal is RM. So this is equal to half into how much is this? This diagonal one is RM and the other one is 5. And we have this to be equal to 24. So this is from 1. Now at last, it's a matter of calculating. So RM is equal to 24 into 2, that is 48. 48 by 10, 96 by 5, that is, no, 96 by 10, that is 9.6 meters. Anyways, I did some mental calculation. So this is 9.6 meters. That's your answer. Right? Quite simple. Yes, there's a bit of writing as usual, but if you go this way, it's faster using the property of kite and finding the areas of kite to with help of the triangle and with the help of the traditional formula of the kite.